We're on lesson 3 of chapter 10, which we're going to analyze data. First, we're going to read a two-way frequency table, then we'll make a two-way frequency table, then we'll analyze the situation in a two-way table. First, a two-way frequency table is a tool that divides data into categories across the top and down the side. And here's an example of that. We ask, how many days a week do you exercise? So one category would be how often people exercise. Another category would be men or women. So using these categories, we could break down the data into different parts. You'll notice these 6 numbers are circled in purple. That's because they are joint frequencies. Joint frequencies are data that matches 2 categories found in the body of the table. For example, this 155, that matches the men category, and that matches the 2 to 3 days. So there are 155 men that exercise 2 to 3 days a week. Marginal frequencies then are the ones in the red. That's data that totals one category, which is found on the outside of the table body. So the 700 here, that just measures the total number of men in this study. This 875, that just totals the number of people that work 4 or more days. So when it's purple, it's measuring 2. When it's red, it's measuring the total of 1. So now let's read a two-way frequency table. It says the table shows the results of students naming their favorite subject. So we have the subjects of math, science, English, and we have Miss Bailey's homeroom and Mr. Cole's homeroom. So it asks us the question, how many students in Miss Bailey's homeroom prefer math? So first we are going to start in Miss Bailey's homeroom, and we're going to go to the category for math. So this is where it meets right here. So we would say that would be 8 students. Now it asks us how many students from both homerooms prefer science. So that's going to be one of those marginal frequencies which total up 1. So we need to find the total for science for both homerooms. So here's science, and here's the total for that. So we would say 13 from both homerooms like science. Now we get to make a two-way frequency table. So what we're going to do is we're going to take all the information that we can and place it into a two-way frequency table. And it's kind of like solving a puzzle where we have to fill in the missing numbers. So it tells us there are 175 freshmen taking a foreign language. Of these, 88 take Spanish, 46 take French, and the rest take German. No one takes more than one language. There are 42 boys taking Spanish, 31 girls taking French, and a total of 89 girls taking a language. So let's start putting some numbers in here. So it says there are 175 freshmen taking a foreign language. So that means all the students taking a language would be 175. And since they could be either boys or girls, that's going to go in the total for boys and girls as well. So it says of these, 88 take Spanish. So that means that the total for Spanish would be 88, boys and girls. 46 take French, and the rest take German. So we actually could figure out German because we know that the total has to equal 175, and we have the totals for Spanish and French right here. So we could do 175 minus 46 minus 88, and that tells me that there's 41 taking German. Now it tells me that there are 42 boys taking Spanish. So that means boys taking Spanish, these two columns right here, give me 42. 31 girls taking French, so if you go to the girls row in the French column, that's 31. And then a total of 89 girls taking a language altogether. So the girls total is 89. Well, one thing we could figure out is how many girls are taking Spanish. We know that there's 88 total people taking Spanish, 42 of them are boys, so 88 minus 42 would be 46 girls taking Spanish. Now that I've done that, I've seen that I can figure out all the girls except for German, and since that's the only one that's missing, we could figure out how many of those would be. 89 minus 46 is 43, minus 31 equals 12. And now we can do simple subtraction to find out how many boys are taking each language and then the total number of boys. Total of 46 taking French, 31 girls taking French. That means that there are to be 15 boys taking French. Same thing with German. 41 total taking German, 12 girls taking German. 41 minus 12 is 29. And now we can find the total number of boys either by adding up all the boys taking a language or subtracting the girls from the total of 175. That'll still give us the same answer. We'll do the adding method. 15 plus 42 is 57. Plus 29 would be 86. And lo and behold, 86 plus 89 does equal 175. Now we can analyze the situation in a two-way table. So this table shows where students at a university live. So they either can live on campus, they could live off campus, and then you have the total amount here. And it's divided among men and women with the total number down here. So it asks us the question, do more students live on campus or off campus? Well, here we have the on-campus column. We have the off-campus column. We're going to need to look to the total for the on-campus and the total for the off-campus. So that tells me that off-campus has more because it's a bigger number than on-campus. So we'll say off-campus. So since that's true that more students live off campus, is it also true that more women live off campus than on campus? So if we look at off campus and on campus for women, we see that 3,800 live on campus and a little more than 3,700 live off campus. So even though it's true that more students live off campus than on, we would actually say for women, it's actually more likely that they would live on campus. So we would say that this is not true actually. It does not follow the pattern for the whole population. And that'll happen once in a while where the categories behave differently.